this video clip you'll learn about parallax error, human error and the meniscus. So these are three words that you might hear quite a bit to do with scientific investigations. Meniscus you might not hear about for every single investigation because that involves measuring liquids, but parallax error and human error are things that you need to consider whenever you are doing an investigation and need to talk about how you will keep your results accurate and reliable. So we'll start with parallax error. If you Google parallax error and have a look at the images, you will find a whole bunch of different stuff on parallax error and what it looks like. So if you have something that you are measuring, for example, looking at a liquid in a measuring cylinder, if you look at that liquid from above, so here this eye is looking down on the liquid from above, so if you are standing at full height looking at the level, then the level of the liquid is going to look lower than if you look at it from below. So if you crouched down and looked up at the level of the liquid, then you would see the level as being higher than what you would if you were standing at full height. If you crouched down or held the measuring cylinder up or supported it up so that it was at your eye level height, you'd be looking straight on to the measurement, and that would give you no error and the accurate reading for that. So parallax error means to look from above or from below at something, and we don't want to do that. We want to look from eye level. So if I show you a different image, we can see this one here, for example. So here, when the person is standing up and looking down on the base of the meniscus, which is this lowest part here, they see the level as being at 19.62 millilitres. A person who is crouching down looking up at the meniscus is going to see it as being 19.82 millilitres, and the person who crouches down and looks at it from exactly eye level is going to see the correct result at 19.7 millilitres. So that's why it's really important to make sure that whenever reading measurements, and the same thing happens for rulers, so if this wasn't a measuring cylinder, if it was a ruler and we were looking at a line on it, then you would need to make sure you're doing it from eye level to avoid parallax error. So, let's say parallax error is when someone looks at a value reading on a piece of equipment, such as a ruler or measuring cylinder, but looks from above or below eye level. This makes the value higher or lower than it actually is. To avoid parallax error, you must read pieces of equipment such as rulers and measuring cylinders from eye level. This may mean you need to crouch down. Okay, so that is parallax error. If you want to put these in your notes, you can. Otherwise, you can refer back to this video. Human error is kind of similar. Parallax error is a form of human error, but the human error that we're normally most concerned about is when people miscalculate or misread stopwatches. So things like delayed reaction times or not clicking on or off on the stopwatch as quickly as what you should will contribute to human error. So human error is when people are too slow or too fast at taking measurements. Usually. This isn't always the only way of doing human error, but for most of the stuff we do, this will be the case. So when you're too slow or too fast at taking measurements, it is to do with reaction times. To avoid human error, in experiments you should always have the same person doing the timing, or it could be reading of a ruler, to ensure that they are doing it the same way each time. Another way that you could avoid human error would be if you had more than one person doing the same job. So you might have 2 people doing the timing, and then those people would average the results. So like for example, if you're timing swimming sports races, then you would have 2 or 3 people on stopwatches timing the same person, and then the average of those 3 people's times is taken. So similar to when we do an experiment, we also repeat trials during experiments, then average the results to avoid any human error. So it's just something to be aware of. Finally, the meniscus. So the meniscus is something that you need to worry about if you're talking about measuring liquids. So again, if you Google meniscus, you'll be able to see what it actually looks like. So the meniscus is on any liquid, the lowest point of that liquid. Well, that's the negative meniscus anyway, and that's the one you're most often going to see. So if we look at this image, we can see that this person is trying to avoid parallax error because they're standing at eye level and they're looking at the base point, and that's where they're going to take their measurement from. Here's another example here. So this person is looking from eye level to avoid parallax error at the base of the meniscus, which is this lowest point here. And if we have a look on this measuring cylinder, that's 30 there, so that's 35. That means that this is probably 36.5 or thereabouts at the base of the meniscus. So, back to our notes, meniscus is the lowest point of the liquid when measuring that liquid. So that's where you must measure from. Alright, hopefully those words have helped. So these are the things to consider when you're talking about how you keep your results accurate and reliable.